Hello.
Hello, everybody.
Hello.
Hi. Brian.
Yes,
Hi. This is Itai Nadler. Can I ask something about the standard until people are joining?
sure.
So, y- the main maybe maybe I'm asking something which is obvious, so forgive me. Uh, Um, the main target is that we will be able to connect chiplet from different vendors together, right? And I see that there are a lot of variants, a lot of speed options, and not to mention UCIe options. So doesn't it require some kind of negotiation? Like for example, the USB that you start from the low end and you do some kind of negotiation until you define what are the low end that you can talk to, the two sides can communicate with each other. Isn't that
Um,
something which is
I don't know about specifically on speed, probably the
mhm.
wrong person to ask about that one, but for a lot of the other things, we are assuming out of band negotiations on a number of features. So you're typically connecting to people that, at least with the specs that we're writing here, that you kind of have already discussed these things with.
Mhm. So the out of band interface is therefore to negotiate what is the each side parameters.
Yeah, what I mean by out of band is
Mm.
like you physically talked to the people to
I see.
to make sure that your pieces will talk to each other. I think that's there are a whole variety of things in both BOW and in these various pieces of link layer here that are implementation dependent and
Mhm.
that are you will have to have some level of discussion. The way that I have viewed pretty much all these specs is not to give you a guarantee that two implementations will be compatible necessarily, but to give you a language to have that conversation between two different vendors. So I think there are certain areas that are much more likely to plug into each other
Mhm.
than some other areas. But this is actually something I guess we just talked about in the last time we had a call 2 weeks ago. Um, in that there's so many different possible use cases we have
Mhm.
for running these various link layers on these on the various configurations you can have on BOW
Mhm.
that
Yes.
it's almost it's almost impossible to find the entire space. I think as we go
Yeah.
forward, and one of the things we tried to do with at least the main band link layer was to give people directions
Mhm.
in the form of the profiles and things like that, in terms of like buses and stuff, um, so that it is more
But you
likely that you'll be able to talk to each other.
but you expect people to talk before. The idea is that you'll create the link layer and of course the PHY, and you'll tape it out, and then you'll be able to connect to several other chiplets. So it should be configurable. That's
I
the way,
think
or you think no, even you need to talk prior to that. You need to tape out the correct configuration.
you need to
Mm,
you do need to talk before you tape out.
mm,
Though I will say there is a lot of variance there. So, for instance, this sideband stuff that we're working on right now with the control stuff, that's
mhm,
almost a lot of it is software defined, right? And it's a lot of
mhm,
it is just agreeing about certain things.
Mm-hmm.
Obviously about, about how you're going to deal with orders of operation here. I think there are certain things you definitely have to know before you tape out.
Mm-hmm.
But I think that it's
But the
it's
ultimate.
mostly obvious stuff in my opinion.
Mm-hmm.
Paul may have a different different opinion on that, depending on where you are sitting close to the phi's and things like that. There's definitely some bits there that are you are a little more in the weeds that you do need to agree on.
But the ultimate goal is that you'll have an ecosystem in which a company creates a, tape outs a chiplet, and it can it's like a Lego. You can connect it to other chiplets,
Yeah,
right? That's the ultimate goal, and I think it's
I
in order
guess.
for the market to happen. That's in order for this market to happen and gain volumes, is that it will work like that.
Yeah, I think
Other.
there's definitely an impetus towards that. Um, I don't think what we have done right now with these things, I think what we have done right now when these things is a stepping stone toward that. It's not
Mhm,
a it's not a solution. And
mhm,
I think the good thing about what we have here, both in terms of BOW, in terms of our main bandlink layer, and in terms of hopefully closing to finish here on the sideband stuff, is like I said, you
mhm,
have all of the bits. I think it wouldn't be in a crazy amount of work for someone to write a spec that uses those 3 bits in order to make something that someone could implement to and be reasonably sure that the things would plug together with. But I don't think and none of these specs are written in such a way where independent third parties could write to them and then just be done, right? There has to be another thing, right? Another spec, another phone call, whatever you want to
mhm,
put there that needs to happen. There's just too many options here. And so we leave way too many things up to the implementation because of those options. And we've
mhm,
intentionally, I mean, like talking about just the stuff we're talking about in the control aspect, because things operate so differently. We've intentionally said, we've intentionally decided not to deal with certain things, right? Whether it be the exact level order of testing or the exact tests that you're going to run, or even how you handle errors, right? Because that has
mhm,
upstream implications as well. So we've just kind of pushed that stuff down the road. If you wanted to actually do a chiplet economy, um, blind plug and play kind of a thing, right? All of those things would have to be locked down and either in a follow-on spec or a separate document.
yes.
Just speaking
It's
from our
okay.
little world over here.
I see. So I expect that, okay, you can, talk once you tape out the I think that, you need to be able to tape out your chiplet and then maybe configure it once it's boots up according to the chiplet you connect. But it must be a
Yeah.
generic
The-
in terms that you tape out and it will match other chiplets.
yeah. There's definitely a level of there's definitely some things here. Like I was saying, like the sideband stuff, it's almost all firmware controlled, from our perspective, I think, and the
Mm-hmm,
assumption is anyway, right? So like if you need to change testing order or bring up layer order or anything like that, none of that's hard coded. It's totally flexible. We're all good. I think the problem that you run into, at least from our space here, is missing features because like I said, we have some flexibility. We have some um, flexibility in how you things. As an example, we're talking about a lot about testing right now, right?
mm-hmm.
And
Okay.
there is disagreement about what kind of or training. Training's probably better, but
Mm-hmm,
different things about what's required in order to train the link. Um, and we have flexibility in how we do playback and how we do the random test generation and things like that. Um, I think, like I said, I think the spec establishes an API and a language, to have that conversation between two vendors. But,
Mm-hmm.
and there is a good chance, I'd say a reasonable chance that two vendors would implement something that in the, in isolation that might be compatible, right? Where you can just make small firmware tweaks in order to make sure that they get to something that's functional. Maybe
Mm-hmm.
not the highest speed. I don't know, whatever. But I'm saying that there's just no guarantee at this stage. We don't have that infrastructure in the document or in organizationally to say that there's a guarantee. I'd say, again, not to talk about
Maybe
too
need
much
to.
other standards. I think that, you look at what UCIe is doing, right? And that's much, much more their goal, right? Like this has never
Mm-hmm.
been a goal for us per se. Blind plug and play, economy of silicon sitting on the shelf. I think that's possibly a long-term ODSA thing. It's
Mm-hmm.
never been a short-term goal. But I think UCIe has made this more their goal. But even
Okay.
UCIe implementations I've seen, it's not really a reality either, unless you're talking about two vendors who sat down, did a thing, and now they're saying these things are all fully tested and we can plug in these things together, right?
From what I see, there is no, I see companies that advertise that they have UCIe connection, but all the time they are connecting to themselves, to chiplets so that they
Yes.
made. No one is also for
Yes.
UCIe market.
That's true. That's
So,
true. That's true for my company as well. We have we
yes.
have we have a couple of chiplet things that are
Mm-hmm.
using even with UCIe, we're not because they're linked. This is actually something I was talking about recently with somebody else in regards to this group because they were asking,
Mm-hmm.
can we port our link layer over to other PHYs like UCIe?
Mm-hmm.
And the answer is obviously yes. But the question is because the UCIe is kind of missing that stack right now. There's
Mm-hmm.
like that, half a dozen implementations I know of off the top of my head, of people doing mapping of doing new link layers on top of UCIe. And why doesn't UCIe standardize this stuff beyond, PCIe, or
Yes.
they're extremely simple stream stuff, right? Because you need something on top of that.
I
And
see.
I don't know. But things like that is possible as well. And so you end up with a lot of hardware implementations of those things. And so like from my company's perspective, even with UCIe, who's this is
You
a
are from
goal for,
Alien? Which
I'm from
company?
VeriSilicon.
Ah, very silicon. Okay.
Yeah. And so
Mm-hmm.
we've done implementations, but I don't think we're really guaranteeing any kind of pluggability unless you know both sides of the link. Either from our perspective, unless it's our controller on both sides, or unless it's like somebody that we have had a conversation with, exactly what that link layer looks like, what the integration looks like, and stuff like that.
And also the PHY, not just the link layer, right?
PHYs are easy. PHYs are different because the PHY standardization, especially on electrical and everything, is a little tighter. So I'm not. I mean, there's definitely questions you have to ask about the PHY. I
Mm-hmm.
think. I'm. And maybe that's my bias as a more of an SOC guy rather than a
Yes.
physical
Mm-hmm.
design packaging guy and everything, right? Um, there's maybe that's my bias showing there, but I worry a little bit less about that because those seem to be a little tighter on the definition.
I see. Okay. I'm also more a SOC guy, but from listening to I'm also joining the PHY group, and I don't think it's closer to be also generic in such way you can
Yeah, yeah,
you
yeah.
can
Okay.
connect to PHY with from different companies, but I might be wrong.
Yeah. Okay, let's get on
Okay.
to the heart of the matter
Thanks.
here. No problem. All right. So what's happened? So again, sorry for having to cancel last week. I had some unexpected travel. Been a I don't know if anybody's noticed, been a little double booked lately with work, and so trying to squeeze in this stuff. If anybody else wants to take over editing for any pieces, please let me know. But I've managed to squeeze in some stuff, expanding on what we did last time, which is I think the focus here is at the end of the document, you know, kind of hopefully moving towards the finish line here. Breaking up the PMR commands and making sure that we have at least a adequate top level description of some of these things. Because in some of the cases, I think in our previous discussion, we decided that the name wasn't enough to understand what the command did. So last time, I think we kind of brainstormed some bullet lists that I've crossed out now in the document, and I've started adding verbiage. So I think I'm going to I think the goal here is to go through this and then call out anything else that's needed to be added to these command descriptions on the PMR side. All right. So as we discussed, I'm just going to, you know, just so everybody doesn't have to mentally read while I talk, I'm going to go ahead and just read this out loud. And then if you think we need to add anything, then we'll do that. Okay. By the way, I removed the no-op. Again, I think that was kind of the consensus last time, and there's not really a use case anymore for it. If people find a reason to have a no-op, then I'll happily add it back in. Anyway, all right. So the link ready command is used to request the main band link transition to the operational state. While an implementation can request this transition in any stage, it is normally set in the IBU stage. The link only transitions once both sides have made this request. I think that text is consistent with what I captured last time. All right. The reset command is used to request the main band link move into a training mode in the EST state. I think that means establishment. An error-free ACK to this request completes this transition. This request can be made by either side in any state and can be caused by a number of implementation determined factors. Temperature changes, software flushes, bus errors, etc. Resetting individual slices in a link may cause those slices to differ in stage from others in the same link. And again, that was a takeaway that we added last time. I'm kind of leaving that open-ended because I'm a little unclear on exactly how that how the link deals with that. But I think that's such a I think, at least from the conversation I got last week, that's a minority of use cases, and that those implementations can kind of deal with that state if they run into it. I think most people will be doing the whole thing, right? All the slices in a link. All right.
Yeah, I agree.
All right. So the next one is it's pretty much just things we've talked about before in terms of requests done. But I've kind of just moved some text around. Here, I'll read this. The request done command, partner previous request done signals the completion of a previous received command when an acknowledgement has been requested. ACK-REC bit. The ACK-REC bit is ignored for the partner previous request done. This is a really long name. Messages. See above section. Oh wait, I need to add a cross-reference for more information. Note, commands that request state transitions are encouraged to use the ACK-REC bit to ensure both sides have are properly synchronized. So both sides of the link. That's a new word. To ensure both sides of the link are properly synchronized, a request done response to a state transition implies both sides have successfully made the state update. And I added this section, this little blurb here, this note, because we do most of the transitions based on specific commands. That's kind of, I called out this last time in the conversation because it wasn't clear in the states, you know, exactly when those transitions are. And so again, you know, Ram mentioned some commands will cause this. So I wanted to make that very clear when this happens, so that both sides understand when behavior is expected. Okay, so next section. So Ram, I tagged you just the other day on this, and again, you haven't seen enough to take a look, but like I think this section right here, these calibration and this disable training pattern wasn't entirely clear in our conversations last time how this is used. So if you
So I can speak first. So basically, like we discussed like 2 weeks back, right? So
yeah,
for the calibration, so the way bow spec is, the phi spec is specified. The TX calibration can happen on both sides, independent of what the partner is doing. But then once the TX is done, for RX calibration, you need the partner to be transmitting some specific patterns, right? So you start that calibration. The RX side waits until the TX says, "Okay, I'm ready," and then the RX starts saying, "Okay, give me this pattern so that I can do this calibration step." And then once that is done, it asks for the next pattern. So you have like multiple steps, like your VREF calibration, your eye training, and whatnot, right? So each step requires a different pattern to be transmitted from the transmitter side. And I think the disable training pattern is for the case where the RX has completed all the steps in its training. So it now, I mean, it is kind of redundant because it could have simply said, "Okay, I'm done training. I'm in the link ready state now." So the transmitter can then just turn off the any patterns, and it can enable the main data path, because all these patterns are being transmitted in the same lanes, right? So the data path is blocked during this time. So I mean, you can treat that as a redundant extra state to let the transmitter know that it can now stop transmitting any patterns, and it can move back to directly sampling the data path signals that it needs to send out.
okay. All right. So I think I'm missing a little bit of terminology. What is the difference between calibration and training here?
I think maybe that is used interchangeably. I think
Okay.
it's the same thing. Calibration and training can be used interchangeably. So maybe you can just call it training. That's fine.
Well, okay. Partner full calibration required by link ID. Okay, that's the name of the command that we have. That's the only thing that says calibration, right?
Right.
But we have all these other things that are used that we've already kind of talked about moving into the different training states. And in order to start trainings, what do you actually use this command to do, though? Since we're already using these other commands in order to set the individual trainings to start, etc. What does this do?
Right. When this was designed, right? So you, for the link side, you have certain link specific items that you need to do in order to call the data link layer to be up. And then you also have certain things that you need to do on the phi side in order to call the phi side up. So basically, we wanted to segregate when we say the phi is trained versus when we say the link is trained. Now, the
Okay.
difference between the two is for the phi training, you're training individual lanes of individual slices. So you bring up all the lanes and you say, okay, both sides are now lane logged, and they can make sense of the entire data that is being transmitted across all the lanes. Right. So once that is done, then you need to go to the link side training, where the link side training basically logs to the framing structure that is defined in the link layer protocol. So then in the bigger spec where this will go in, we specified some framing structures for sending and receiving data. So we need to lock onto the framing structure, and that's when we say, okay, my DL is now logged. Now I can start my real data path traffic. So there could be cases where your phi is still good, but then you lost your frame lock, meaning
Yeah.
you're no longer able to make sense of the frame boundary. So you may want to just re-establish the data link layer at that time.
Okay,
And then there
I
could
think this may answer another question I have. So is this how we transition from SBU to LBU then?
LB, yes, I think so. Yes, SBU is basically slice bring up, which is basically the file complete, and then LBU is basically the data link bring up.
Okay, yeah. So this is a piece that was missing, I think, when I was doing my editing earlier. So because we have explicit transitions, I think for let me double check. So the links to just we don't have IBU. We need to understand that one in a second. But I think we have, let's see, EST to SBU, SBU to LBU, LBU to IBU. So here, and I might need to reorder everything so that it actually matches that. Let's see. Wait, okay, so this is how we get to operational.
Yeah, and I believe IBU was just meant to be there, but it was mostly vendor controlled. It was not meant to be a spec controlled thing. LBU
Gotcha.
is basically something that we wanted to make sure that we are at least spec controlled. I think IBU, I think some designs required credit handshake as well, and all of that forms a part of the IBU where we make sure that the interface, the knock fabric interfaces at that level is up.
Gotcha. Okay, so there, let me so we do have the EST to SBU here. And then so I think the only one we're mentioning, as you mentioned, I can add a note on the IBU. I think the only one we have missing is LBU. Okay, yes. And so, okay, commands are set. So these are all during LBU. We don't talk about the LBU transition. All right, so that is something. Okay, and then, all right, let's go back up here. So the calibration. So this is the actual transition to LBU. This is during what stage? This is 111, which is, what did we say earlier? This is general, which is always confusing. All right, so should that actually be updated? So this should, you don't ever do LBU unless you're in SBU, right?
That is correct. I
So
mean,
should
you
these be a
should at
different
least have
stage?
your slice bring up complete before you can even do LBU.
Okay, well, okay, I'll leave it as is. I don't know. Again, I guess it doesn't hurt anything. So this transitions to LBU from SBU. Okay. And then hold on, let me make sure that I'm clear on that. Okay. And then so I'm gonna move this guy down to the other ones where you have the LBU stuff in. Oh yeah. The question was, okay, what is the order of this? So I get into this in a minute with the other transitions. So this is the link bring up. So in the EST to SBU, the TX does that transition on its own, and then it sends the command in order to transition over the RX. And then when the RX acts, then it's transitioned, and then RX will then send individual pattern commands or whatever to the
Right.
TX side, and the TX side will transmit on the main band.
Right.
Is that the same process for LBU, or is it a different process for LBU?
So for LBU, it happens at the link side, right? So because both sides, the file is ready. I don't think we specified a specific a pattern of sort for LBU. LBU, I think both sides need to lock onto the framing structure, so they need to identify the framing structure. And last, I think it won't probably be in this sub document. It will be probably in the main document. So from a link perspective, I think there are, if I recall correctly, there are three main things that you need to do. One is your a valid byte detection, where you detect your first location of your first valid byte. So you need to do a word rotation for that. Then the second one is lane reversals, where if you have multi slices being treated as a single unit, there is a possibility that your slice 0 is connected to slice n on the other side if the other die is rotated. So you need to detect those lane reversals and realign your data to what is being transmitted. And then the final stage for the link bring up would be to lock on to the framing structure. So you'll detect a start of frame, and then try to interpret the framing structure from that point onwards. So I'm not sure if the main document already specifies all of these. At least these three steps I think we documented back then. I'm not sure if that's still there.
Okay, so what you're saying, it sounds like, again, it's just more, it's higher level training to a degree,
Correct.
right?
Higher level training. Correct.
So it sounds like okay. So the RX side determines when training is done, right? And then it wants to move on to this next level training. So again, I think as what I have in the open here, it sounds like the RX side makes this transition from SBU to LBU itself, and then signals to the TX side, all right, we're doing this transition, and then we're going to switch the tests that you're going to be transmitting. Is that correct?
Yes.
All right. So I think I'm just going to document it as that for now. And then, if we have, because I can't imagine how else that would work from your description.
Right. So I think the main reason why there was this disable training pattern was because when you do the SBU training, right? So SBU training, the file layer itself hijacks the main band and transmits data that it wants to transmit. But when you go from SBU to LBU, you want the PHY to release the bus, a main band bus, so that your higher level link can start transmitting data to the other side. So I think it is a redundant state. If you simply act saying, okay, my RX calibration is done, I think that can also be interpreted as an implicit request to disable the training pattern.
I see. Okay. So I think, so you're saying the initial intention was to use these together. So first you send disable training, then you send the full calibration required in order to transition from SBU to LBU.
No. The full calibration required is basically for the case where you are already up, but then you're detecting errors. So your first line of defense to recover would be to see if you can achieve frame lock again. So you will just do the LBU training, and if your LBU training fails, then you would send a request for saying, okay, I need to do a full calibration. So the full calibration request is for I think both during the startup, not during the startup. I think during the startup it is all implicit, but it would typically be sent when you're already in the link up state, and then you encounter errors or you encounter certain other conditions like your temperature suddenly changed, or you lost your frame lock, or you saw too many ECC errors on the main band, or FEC errors on the main band. I think that's when you do the full calibration request.
Okay. All right. I'm a little, let me. So were you saying a second ago that the disabled training is actually what causes this state transition then?
No. So the disabled training is basically to indicate to the transmitter that my RX side has completed doing all the training steps.
Yes, I
So
got
you
that.
can now release the bus. So it is basically indicating to the other side that the other side phi needs to release the bus so that your LBU level training can proceed.
Yeah, okay. But again, what actually causes the transition from SBU to LBU? Is there a command that does that, or you just end training and then just start sending calibration commands?
I don't think. I think that is kind of implicit, right? So once I thought there was one state that says RX ready. Can you scroll up a little bit? Is there a partner
Scroll up.
RX ready indication? Like we have partner TX ready indication. I thought there was one more for
All
RX
right,
as well.
we just walk through them here. There's a link ready, right? But we're already saying that's their transition to
That's for the
operational.
main band, yeah.
Yeah, well, this is all for the main band, but the let's see, reset, request done, and then there we go. Then there's full calibration request, and then there's disable training, and then we have the individual tests, and then more tests. Wait, we have bad lean, we have. No, that's more termination values and tests. And then here's all the LBU stuff we just talked about. There is a link ready to train. Is that what you mean? Wait, phi TX link ready to train. Is that what you meant?
Link ready to no, that one was the TX calibration complete, right? So I thought there was one more for
This
RX
is
run.
sent from the RX side to the TX side, saying that the link is ready to train based on the previous usages of this verbiage. Because these are all commands from RX to TX when it's written like that.
Oh, okay. So if this is from RX to TX, then this should probably read the RX is ready, because what you want to basically tell the other side is that the partner's receiver is also ready. So the partner so one side knows that its transmitter is ready, but it also needs to know that the receiver on the other side is also ready in order to move from
Oh, I see what you're
SBU to
saying. Okay,
LBU.
maybe I'm reading this wrong. So this is okay. So when do you?
So
Okay, so
if you already have
maybe what I
something.
have. So what I've written up here is completely wrong. So let me wait. Where did I just do that? It's okay. So this is all wrong. So this is not what this does. Okay. So let me. Okay. Let's go back to this real quick, and then we'll move down to there because it sounds like
Okay.
that's what's doing that. All right. All right. So calibration. At any time, if you have a frame lock error and transitions link just back into LBU.
Correct. So you'll try to do the so anytime you get an error, you first try to do LBU again. So you go from interface bring up to the ready to the LBU state, and you try to do the link bring up. If the link bring up is not successful, that's when you will request a full calibration and go into the SBU state. So then that full calibration request will force the other side to also enter the SBU state.
LBU state, right? LBU, right?
So, no, the full calibration is basically you want to do both phi calibration and link calibration.
Okay, okay, so we go to SBU, not LBU.
Correct, SBU.
Okay. All right. So okay, but if you're going to SBU, we already have commands that do that though.
Yeah, I feel we probably have a lot of redundant commands right now.
Yeah,
is
so
what
we
I
have
think,
we
yeah.
just talked about this one last time. We talked about reset commands do the same thing.
Right,
Let's
we
do
already
it.
have the reset command, so maybe we don't need this. We can probably simply send the reset.
So is there something that says Is there a situation where I would like to do retraining, or I would like to do relink training and not do refi training? Is there a situation you can imagine that we
Yes,
would need to do that?
yes. Anytime an error happens, you will first try to attempt to do a link training alone.
Okay,
And
so
only if
then
your
we'll
link
just
training
use
fails,
this calibration thing in order to go to LBU and not SBU.
then maybe we should probably also change the naming then so that it is clear. Because when you say full calibration, I may be biased. I don't know how others are reading this, but the way I read this is you need to restart your entire calibration as if you're starting from time zero.
Okay.
So I'm not
Well,
sure
here,
if
let me hold on. Let's talk about the reset then. Let's see, reset. All right, reset command is used to request a move to, this is to the EST. Okay, then you would go to EST. Well, this is kind of the same thing. You go to EST and then you move to SB, and then you basically request an SBU.
correct.
So it's kind of it is doing kind of the same thing. So
Correct.
again, if we're saying if we want this to move to LBU, what would you call it instead of calibration? Or and is there not another command? Because I guess the
So can you go to
general.
the LBU section to see if there is anything in the LBU section to
I mean, hold on a second. Let me copy this before I load it. So there's a ready to train command here in the LBU section, but that seems not something you would run. It is specifically has the LBU stage.
Yeah, I think if it is having the LBU stage, then maybe that is probably. I mean, TX fight TX probably is a misnomer here. It is probably it should have read link ready to train or something like that. If this is meant for the LBU state, I'm not able to recall whether this was something else or if it was meant to do the link level training. If it is an LBU state and if it is meant to do link level training, then we should probably call this as link ready to train.
I think it says that phi TX link J ready to train, right?
Okay. Yeah, that phi TX is kind of a little misleading because are you talking about the phi or are you talking about the link you're using? I mean, I feel that the way we named it, it's a little ambiguous.
I see what you're saying because we actually we don't say the phi down here, so maybe we just delete this TX link ready to train.
Right.
Okay. So again, based on the previous discussion, RX makes this move implicitly and then
Right.
transmits this to the. This is a wait. TX ready to train. Should it be? Again. RX makes this move implicitly and then sends a request to the TX to make this transition, right? So
Right.
maybe we should call this add a rec here. So
Right.
rec instead of ready to train, say rec to train.
Yeah, rec to train is also fine. Yeah, rec to request to train. Yeah, and then yeah, I also made a note during that time, like months back when we were discussing this, that I mean, at least in my design, the way I implemented, I do not have any of the PMRs for these things. The reason being, at this point, the file lanes are already active. So I use the main band itself to transmit a few bits of the main band itself to transmit these indications to the other side. So that way I don't have to go through the PMR, which is an extremely slow process.
Okay.
So you technically for the link bring up, you don't need PMR, but I believe Bobby preferred to keep it, and at that time there was a common request from others as well to keep it in the PMR for completeness. I'm not sure how Paul does it though. Maybe if Paul can chime in, that would be good too.
Yeah, we completely bypassed the PMR methodology.
Yeah, that's what I would expect, because once your phi is up, you no longer need to go through PMR. It is only needed when the phi is not up.
How are you communicating over the main band phi if you don't have these things set up? I mean, you're just sending, but yeah,
So
actually,
I reserve I think 2 or 3 bits of the lanes. 2 or 3 lanes is reserved for communicating the handshake signals, and then
I see. Sorry.
both sides
Okay.
know what it is doing. So it based on the handshake, it will transition from one state to another automatically.
Okay, I got you. All right. All right. I guess back to the conversation we had at the beginning of the meeting with Atai. That does not seem ecosystem friendly.
Yeah,
Unless
I think
we
that was the whole intent behind. I mean, one of the reasons was basically to fold all the LBU states also into the PMR, was basically
right.
to make it a little bit more ecosystem friendly. But yeah, I mean, yeah,
I'd almost, again, if we wanted to speed these things up, and maybe maybe this is a later discussion we need to do in terms of
right.
speed optimization, I would just add another command to the physical layer
Okay.
for state transitions or something like that, right? You know what I mean? I mean,
Yeah.
something that is, if you don't want to go through the whole firmware stack. But I don't know. Okay. All right. All right. Not adding bits at this stage. Okay. All right. Let's move on. All right. So, okay. This makes more sense. Thank you, Ram. All right. So that command sets the new state. Do we need more information there?
No, I don't think we need any more information. And I think you can also treat this as an implicit request for phi disable training. So with this, you probably don't need the phi disable training command as well. But yeah, I mean, I'll let you decide whether you want to keep it, or for completeness sake, or you prefer to remove it so that it is one less thing to worry about for the vendor who is implementing this protocol.
Okay, let's go back up to that real quick. Before we decide to remove it, let's see, you have is there any reason like you would want to cut training short?
That's a good point. So at least the way we had it set up, everything was hardware based, and we did not have a mechanism to short circuit things. So, but maybe other implementations might. I'll let Paul chime in.
Yeah, no. So we do things differently. We actually don't use the main band. We do use the sideband, but we have our own proprietary messages that we use to transfer between these states. So I don't have a preference one way or the other about, these definitions.
Okay, well, I'll leave it there in case somebody has something. So I'll say use to end SBU, and I'll have to see add note LBU command can also be used to request training ended early, but may not be guaranteed. Look good? Anyway. All right, let's go ahead and move on before we run out of time here. All right, so this talks about normal training, not linked, the phi training. The TX side of the link moves from EST to SBU when done with localization initialization. Once in the SBU stage, the TX side sends ready to train command to request sends a ready to train. Sorry, let me say that again. Once in SBU, the TX side sends a ready to train command to request the RX side move into the SBU state. Once both sides have transitions, the other side, sorry, once both sides have transitioned, the other above commands can be sent by the RX side to, I don't know why I'm mentally inserting words here. The other above commands can be sent by the RX side of the link to request training patterns be sent to by the TX. I think that's all pretty straightforward. The above command, sorry, these are more link. Yeah, these are just more training things. The above commands are patterns executed. That's not right. Commands are, yeah, the above commands are executed. Oh, that's, never mind. The above commands are pattern. I should say this differently. Are patterns being requested? The above commands are patterns being requested by the RX side of the main band link to set up pattern playback from the TX side. I'm going to reword that in a little bit. The pattern ID in field 1 of some of the commands is an identifier that is associated with the pattern that will be uploaded by subsequent commands. So I added an order there. I hope that's not an issue because it wasn't really defined previously. Pattern ID should always be set before the associated patterns. Missing bits in a pattern are assumed to be 0. That's if somebody like only uploads the lower and doesn't upload the upper or something like that. Well, commands that have a bit ID are for programming patterns on specific pens. Excuse me.
So for the patterns, would it be less error prone if we say that the entire pattern should always be uploaded? Because there could be a case where somebody left out, I mean, they sent something for the upper bits, but the next time they did not, and that was probably a mistake or an oversight. And those kind of bugs probably might take time to catch. So maybe do you think if it would be better if we say we always transmit the entire pattern?
That's, yeah, I don't have a problem either way. I think we just need to, we would probably need to specify an error is sent if pattern bits are missing in that case. Does that make sense?
Yes, I think that probably is more annoying. So I think what you have right now is probably better.
Because I mean, what would the alternative would be you just don't play the pattern. And then that's just as equally bad, right? So
Yeah, okay.
either you assume some bits or you give an error. It would be my suggestion.
Okay, assume bits is fine then.
Do we need, oh, here it is. Okay. Yeah, so we have, I think I'm going to move some of these around because I think we have part of them. These are all in the SBU, but these are just more patterns. So I'll regroup them with the other patterns and leave that description as above. And then I'll break these guys off as individual things. And so the first one is the termination. The setfi transmit termination command that has a termination ID. Term ID is for the RX side setting the TX side's termination value during SBU. At this time, only 0, 50 ohms, and 1, 150 ohms are valid. All other values are reserved. And then the setfi TX bad lane command establishes which main band lanes are unusable during SBU. The repair fallback lanes are defined in the BOW5 specification. And this is, I need to I need to add that this is sent. Let's see, commands. I need to. I'll add a little verbiage saying it's only sent by the RX side. And then we just discussed this in.
Sorry. Can I interrupt Brian for a sec?
Yes.
So it seems implicitly we have the RX side determining the termination values because there's a command to set
Yes.
the TX terminations and there's no command to set the RX terminations.
Yes. There
Is
is
that
no
what we want?
there's no symmetric command here.
Yeah.
Yeah, I think, Paul, that is because of the way how the BOW spec is, the file layer spec is specified, right? Because for the file layer, for the TX calibration, you really don't care what the partner RX is doing. So you do not care about any additional RX terminations when you're doing TX calibration. But then the reverse is not true. You need the TX to be terminated in a certain termination mode when you're doing certain steps of the RX calibration, and that's the reason why you do not have symmetric RX termination commands.
Well, like assume that there's only like one intelligence on the link, right? That there's not an MCU on both sides, right? That one side's dumb, the other side's smart, right? If the smart guy's the TX, he's the only guy who knows what the RX termination should be.
No,
There
but
needs to be
in that case, he's the one who's driving the RX calibration. I'm trying to recall. I think we discussed this way back when there is only a unidirectional link. I'm trying to recall what we decided because I mean, even if the intelligence is on the TX side, the TX side has to set its own termination and then drive the RX side to do the calibration steps. So so you never have to terminate the RX side at all for any TX calibration, if that makes sense.
No, I mean maybe for calibration, but I mean there are going to be links that need RX termination, right? And we don't want the software firmware intelligence to be the one to set that. Again, there's only one set of intelligence somewhere, right? It could be on the TX side. In that case, someone's got to go into the RX guy and let him know that he needs to turn his terminators on. Right?
In principle, yes, but I'm not sure if we are defining the sideband as something that is unidirectional. The sideband, I thought we always agree that sideband is going to be both ways.
It will be both ways,
the-
but no,
Yeah.
I grant you that it's bidirectional, right? But I'm just saying there will be implementations where there's only intelligence on one side of the link, right?
Yeah, I'm trying to see if we agreed on that on the 5 spec as well. So I thought we are going to do that for certain slices, but then we'll always have. I mean, when we are using bow, we always assume a bidirectional link is what I recall. Not sure if there are other implementations that also talk about unidirectional implementation.
No, I'm not talking about the directionality of the link. I'm talking about whether there needs to be intelligence on both sides of the link or not.
But you would need that intelligence, right? If your sideband is bidirectional, then you need somebody to be processing the PMRs on the other side as well. I'm not sure how you can have a bidirectional sideband with intelligence only on one side.
Okay, so let's pop up a level, right? So I understand what you're saying now that the PMR is kind of built to be handled by firmware. So there are applications where one side's going to be a dumb IO chip, right? A dumb IO chiplet, and we don't want to put a processor inside him. Right? I'm at the highest level of BOW, right? We want to be able to support, applications where there's a big SoC in the middle and it's got lots of little dumb, stupid IO chiplets around him. Right? And we don't want to foist a firmware, a processor on each of those dumb IO chiplets. So what's
Right.
the use case of sideband in this situation?
Right. So in that situation, I think the original design for the sideband was basically meant to access the entire address space for the link on the partner as well. So if the partner side does not have any processor, or it's a dumb IO chip without a CPU, then you would probably have to go in and directly access the individual 5 CSRs that control the calibration on the partner side, and then your entire calibration is going to be controlled from the TX. You will still be using the sideband, but you won't be going through the PMR. You will be going directly into the partner register space and writing to the individual CSRs there. But then that also assumes that the dumb IO chip needs to have some hardware-based processing of the sideband messages, and that it can convert those sideband messages into its local CSR writes. Otherwise, this scheme won't work.
Sure. Yeah, no, I'm happy with all that. That makes sense, Ram. Thanks.
Folks, I think we
Yeah,
dropped-
so, oh, yeah, sorry. Okay, so yeah, just so I'm clear, we can say, so yeah, so all we're doing is setting up a mailbox here with the PMR, right? Basically. And I guess just to complete Ram's thought here, where the actual processing of the commands and how they're being done is not defined in the specification. So if because the actual the sideband layer is just register accesses, then anybody can be reading that register, and anybody can be doing the other pieces of that link bring up, or sorry, of any of these stages, right? Of that transition from command to implementation. But I guess one piece there, like you said, Ron, ideally you want some of that in hardware, I think, but I guess that could be implementation specific about how you make that layer. Yeah, anyway. I think again, if I was doing a very simple thing, if I was doing an IO chip, I think well, I don't know. I guess you could still do a even in that case, right? I think it still makes sense putting some sort of very limited microcontroller in that situation, and then just deploying firmware over the sideband or something like that in order to do some of the basic functions and make it give it a faster bring up. But I don't know. Maybe I'm overthinking the problem.
Yeah, that might be a reasonable solution, but again, we don't want to push people to have to do that. That would be bad from a standards perspective, I think.
Yeah, I think I don't know how we would. I don't know how we would do this the way we have built things so far. I don't know how else you would. I mean, obviously, like we said, you could move you could be real slow and process on both sides from one, but I don't know what you would. I think we would have to if we really wanted to enable this with absolute minimum and all intelligence on the other side, it almost makes sense to rethink the standard. I don't think the standard's not built for that specific use case, I guess, is what I'm trying to say.
Well, I think it is. Ram pointed out that you can access the entire CSR space.
Yeah, but then it becomes
Right.
like, what's the point of the standard?
It's a communication medium that, can be used across chiplets.
Well,
I mean,
right. So, okay. So my point is like, then basically you're just using the sideband link, the sideband address space, whatever we're calling this sideband protocol. We call it the sideband protocol, not the actual link control protocol, because link control protocol is really all about PMR. And if PMR processing for both sides happens only on one side, why bother with any of this? Just use this.
right. And so some implementations will.
Okay. So I just want to make clear that, like, you're half the specification you're kind of tossing, which is fine. But I mean, I think if you really wanted to enable this, you would rewrite this slightly differently. or not even slated, but you probably rewrite quite a bit of it. But my point anyway, like this whole half of the spec is not used in that use case. Okay, all right. I think we're close to being done for here. And so I'm gonna reword some stuff for this for next call. It sounds like I've captured the solutions that opens, and then we can review that to see if we're closed on these command descriptions, which I think is really the last thing. I think the only thing we have again past this, again, I've said this before, but fingers crossed, is just one more review of the whole spec before we give it to wider reviews. But I'll do a double read hopefully before next week. And then we can hopefully if there's any opens I find there, we can talk about them.
Sounds good. Thank you so much, Brian.
Hey Jeff, did you want to bring up anything before we close? I don't know if anybody needs to run right this second.
Yeah, I mean, it's just the general idea of do we want to support the link layer running on top of UCIe FDI streaming layer? It seems to be a different topic from what you guys are discussing here in terms of the sideband, but that's one interest that I'd like to discuss and understand if it's a possibility in the future.
So yeah, so let's if you're okay coming back to another call when Helia's here, I'd like to have her weigh in on that. I think kind of as I think generally from my perspective, I think that's a worthwhile goal. Whether you can fit it into this exact group in the standards body, I think is the only open question there. But
Okay.
I don't know if anybody else has any thoughts on that. All right, let's if you can, well, yeah, we'll just let's see if we can carve out some time in the next call, and have at least a quick discussion on how we think that's applicable.
Okay. Sounds good.
All right, thanks, guys.
Thank you, Brian.
Thank
Take care. Bye.
Bye.
I know.